Okay, my name is Erik Rasmussen, and this afternoon I want to talk to you about visually coding back-end logic using state machines. But before I get too far, let's talk about what are state machines. State machines define an initial state and a finite number of other states. That's why sometimes they're called finite state machines. And then transitions between these two states. And this is important because only some transitions can take you from one state to another. So if you're in the playing state and you hit the play button, nothing's going to happen. And then perhaps some other side effects and other things. So on the front end, what we generally do is we instantiate a machine, and then as the user interacts with the UI, events are sent to the machine. Like maybe you click on the thing to open a dropdown or something, and the machine transitions to a new state, potentially, dropdown open, and then we re-render the UI based on that. This works really well in React, where it's a reactive, declarative UI. And in general, machines are on for the whole lifetime of the component or the page. But things are a little bit different on the back end, because on the front end, normally state machines have like a final state. Either you shut them down because you change the UI, or you get to a final state where the machine shuts down and then it's no longer listening to events or anything. But on the back end, we need what I'm calling pause states. These are states where when we get to this state, we need to stop and flush all of our content back down to the client so that we can update the UI. And not all states are pause states, because maybe you get to a state and you need to be fetching something and you need to wait there in that state until the data comes back, and then you transition to another state. And then that state can be a pause state that sends the data back to the user. But on the front end, remember, the state machine was just instantiated and was there in memory. But on the back end, we need to figure out where to persist the machine, because HTTP is fundamentally stateless, and we're moving to serverless functions and moving everything to the edge. And so somehow we need to figure out where to put the machine. So we've got several options. You could serialize it to a database or something, or to some sort of session store, maybe Redis. But for the purposes of this demo, I'm going to use the humble cookie, because everybody loves cookies. And we have another problem. In computer science, there's this thing called the halting problem. And the halting problem states that it's mathematically impossible to know if a computer program is going to return you a value or if it's stuck in an infinite loop. You just cannot know. Like maybe it's about to return, and if you cancel it, then maybe it was going to return, but you just can't know. So it's really fundamental when doing state machines on the back end that we define some sort of a timeout. We set a limit to how long we're willing to wait for our machine to get into a pause state. So how are we going to do this? Well, my favorite state machine library is called XState. And this year they've released an API that does exactly this. And it's called waitFor, and it looks like this. Now, typically when you use a state machine with XState, you have this interpret function that is going to turn this machine definition into a service that you can then interact with. So I called my function async interpret. And you give it your machine definition, and you give it how long you're willing to wait. Now, as an aside, when you're dealing with durations and stuff in JavaScript, I highly, highly recommend that you put the unit of time in the variable name, because sometimes you want to deal with seconds and sometimes with milliseconds or days or whatever. Just a pro tip. And then we give it the initial state that we're going to start with, and if we have an event to send initially, then we will send that. So the way this works is we use the regular interpret function to turn this machine definition into this service that we can use. And then we start the service and we say start in this initial state. And then if we have an event, the event's optional, then we will pass it. And then we call this wait for function. Obviously, it returns a promise. We're awaiting this function. You give it our instantiated service already. And as soon as we've said start on our service and we've given the event, it's like processing things and doing things. So we give it our service that's running right now, and we tell it how long we're willing to wait. And then we give it this predicate. And this predicate is going to be called anytime the machine transitions into a different state. And if this predicate returns true, then the promise is going to resolve, and we can give our data back to the user. And if it returns false, then it's going to keep waiting. State.done is true when we get to a final state. And there's currently no first-party way to make pause states, but xstate does allow you to apply arbitrary tags to your states. So for my implementation, I've labeled the states that I want to be pause states with the pause tag. And so when we get there, we're going to return. So that's all we have to do to run our state machine on the back end. So let me talk a little bit about the architecture of what I'm going to demo here. States as routes. Now, if you think about it, routers are fundamentally state machines. You go to a web page and you're on the route /, and if you click a link, that's an event that transitions you to another route, another state. If you hit the back button, then you're going to go back to the other state. So your router really is moving you between these different finite states. You're never in more than one route at a time. And speaking of the back button, it's really fundamental that we don't break the back and forward buttons. Because users of websites have been trained what those mean, and there's nothing worse than a website where you hit back and everything breaks. And also, it's not just back 1 or forward 1, right? Because our browsers let us go back 3 or forward 5 if we've gone back several. So we have to respect that. So basically, we need a way to go to any state in our state machine that the browser thinks that it is telling us that it's in. And for that, we're going to need like a global go-to event to be able to sort of teleport ourselves to whatever state the browser thinks we're in. Like I said, we're going to store our state machine serialized to a cookie, and we're going to use that async interpreter function to run our machine. And we're going to use Remix as our platform that we're going to build this on. And I don't know if you saw the demo earlier with Remix, but it's Remix really loves going back to the web fundamentals and submitting changes and stuff using form data. So we're going to send our events using form data, not a fetch, but a form submission. So how do we do this? Well, we're going to use Remix's form component, and we're going to set the method to post. And we're just going to use a regular old HTML submit button. And one thing that people may have forgotten since the good old days of actually submitting stuff with HTML is that you can put a name and a value on your submit button. And so that's how we used to tell if you were hitting next or previous in your wizard or whatever. And this, when you send the form data to the server and you deserialize it into JSON on the server, is going to give you this object that is exactly the shape that xstate expects its events to be in. But what if we want to send extra payload or something with our event? Well, for that, we just use a hidden input. This used to be super common when, like, editing a record. You'd have to keep the ID of the record you were editing, but not show it to the user, so that when the user submitted, you could know which record to update. And that is just a name-value pair. It's a name and a value, and those name value are going to end up on the JSON when you get to the server. And same thing with the submit button. You're going to set the type of event, and that's going to show up in the JSON. So a little bit of terminology around XState. XState has guards, which are predicates that determine if a transition is possible. If you're in the state and you get this event, check this predicate to see if you can make that transition or not. Actions are side effects, something that causes something else to happen in the system. And the most common action is to save data into the context. And the context is like local storage in the machine. You can think of it like a Redux store or something like that. It's just where you can throw data in the machine. And then there are services. Services are how you do asynchronous communication with other things in the outside world. If you need to fetch some data, or if you need to spawn up a whole other machine and send messages back and forth, those are called services. And let's try to do some live visual coding. So guessing this is Sony. Uh-oh. Okay, good. So this is our state chart for our state machine. It looks a little complicated, but it's pretty easy to follow. Let me walk you through it. So this is an actual editor. I can like move stuff around here. But first, we're going to go through a simulation of what it's like to go through this machine. So this little icon here means that this is the initial state for this machine. We're going to start off in the cart. And these things that loop around back into the same state are actions these are events that don't change state. So if we get the event to increment product, we're going to run this action that's going to increment the product count for that product in our context. And if I click on this, we stay in the same state. Same with decrement product. And so these things in dark blue are the possible things that can happen from this state. I can't click on any of these other ones. So if the user clicks checkout, only where this is a guard, only if we have items selected are we going to go to the next state. So when we click checkout, we're going to go all the way over here to the shipping state. And again, this is another route, another page. And from here, we can go back to cart if we want, and we can hit checkout again. And from here, we can also hit next, which is going to save our shipping data to the context. And now we're in billing. And what if we go back all the way back to the cart? Well, that's going to bring us into this go-to event to take us to the cart. It comes in from the top because that means it's a global thing that no matter what state you're in, it's going to listen to that. So we check out again, we hit next again. Of course, we can go back. And when we're here, we hit place order, and that's going to save our billing information. And it's going to put us into the placing order state. And this is going to invoke a service called place order. And this is an asynchronous thing. It's going to go and talk to the database. It's going to save the things that we ordered and our shipping and billing information. And when it's done, it's going to come back with order placed. And that's going to take us to the order success, which is our final state, and the machine is done. So let's see what this looks like in the browser. As you can tell, I'm a front-end developer. This is my design prowess. So this is our cart, and I can hit plus and here, plus, plus, minus, minus. And this is, whenever I hit one of these buttons, remember it's submitting a form to the backend. The backend is updating the context in the state machine and then serializing all of that back down to the client for being displayed. So when I hit checkout, I go to the shipping route here, And if I hit back to cart, I go back to the cart. I can go back to checkout. And here in shipping, I don't have any states yet to ship to. And this is the sort of thing that we're going to implement. I created this arbitrary requirement that depending on which items you have in your cart, you can only ship to certain states. These are US states because I'm American. So we can't do that. So we need to load somehow between the cart and the shipping, we need to load our states. So let's do that. Where do we need to implement that? Well, somewhere between the checkout and the shipping, we need to load some states. So let's make a new state. Let's make a new state called loading shipping states. And when we're in this state, we're going to invoke a service called load shipping states. This is code I've already implemented. And so how do we get here? Well, watch this. Don't blink, this is really fast. Boom. So now, when you hit checkout, we're going to go into this state instead of the other one. But how do we get out of this state? Well, when our service returns, when our service loads our thing, it's going to give us this event called shipping states loaded. And that's going to take us back into shipping. Now we're almost done. We need to do something with those states. So we're going to add an action to save shipping states. And now those states that we got back from this service are going to be saved into context and ready to be displayed in shipping. Now, as I have been moving these boxes around, this editor has been updating my code. It's this big JSON structure that has all of these boxes in it. And as the code updates, Remix has been reloading that code. So it should, if the demo gods are with me, it should just work here. When I hit proceed to checkout, it should wait a second, because it's an async thing, and fetch the states. And that was very fast. Let's refresh. Okay, we need to kill our state machine cookie. Oops. So here we are. Add some stuff. Hit proceed to checkout. Okay, VS Code was doing this to me earlier. There, it wasn't auto-saving. Now, I said demo gods. It's too fast. Did this reload? So this is the JSON structure here. Save. Well, it's okay, I have extra time. Oh, that's unfortunate. Let's look at this. I bet I misspelled something. Okay. Here, let's do this quickly. The editor was out of sync with the... Oh, I turned off Wi-Fi. That's my problem. No. There. Let me quickly implement that again. Okay, there. Now this needs to be saved. Now it's saved. All right, now it's going to work. Back to cart, add another thing. Now it's loading our states. Ta-da! VS Code, man. Sometimes it bites you. So I'm from North Carolina. I'm going to ship this to me. I'm going to bill it to somewhere else, like maybe Kent and Utah. And I'm going to hit place order, and it's going to take a second to go and do that async thing. And now I was able to place my order. Now, there's one more thing, though. One more little trick here. What if we disable JavaScript? So to prove that JavaScript is disabled, I'm going to refresh the network tab. And these are my JavaScript files that Chrome is blocking. I have no JavaScript here going on. So how is this going to work? Well, previously, when I was submitting my form, Remix was being clever, and it was taking my event and calling prevent default and using fetch because it had JavaScript to do that. But if it doesn't have JavaScript to implement that, it's just going to let the browser default to its normal HTTP, HTML way of submitting forms. So now, when I hit plus here, it's actually sending the form submission back to the server and re-rendering the entire page. But it works. And when I hit proceed to checkout, it's gone and loaded my states again. I can send this to, I don't know, someone. And now when I hit place order, it's all like, this is all working. I can hit back, and that hitting back was actually submitting a form to have that event to change our states. And of course, I can hit the back button and the forward button, and that's doing the same sort of thing. It's using that go-to thing to tell the machine what state to be in. And now when I hit place order, it works. And believe it or not, that confetti is CSS, no JavaScript. Okay. Thank you for bearing with me. Hey, we sort of survived. Okay, so to recap what I've just demonstrated, we're using pause states as routes. We transition to a state that has to do some fetching. Maybe we go to another state that does some other fetching that depended on the previous thing that we were fetching. And eventually you get to a state that is marked as, okay, serialize everything back down to the client. And we used async states to await different data and services that we needed. And we used a timeout to ensure that we don't wait for too long. And we were able to preserve the back and forward functionality of the browser using this go-to event. And we used the platform by sending events past as form data, which is what allowed us to turn off JavaScript and still have things work. So we've heard all of these talks today about reducing the JavaScript that you're downloading. If this is the least amount of JavaScript downloaded, right? And we have this beautiful design tool for designing our backend logic, courtesy of stately.ai. You should check them out. They're the creators of Xstate. And we were able to build this decent, not gorgeous, but decent front-end JavaScript, decent front-end UI without any JavaScript enabled whatsoever. So thank you very much. You can find the code that I was using here.